Good afternoon, everyone. Thank you for joining us for this session. Welcome back to the Confidential Computing Summit 2026, hosted by Opaque and Linux. We are all so grateful to be here. My name is Brittany Kaiser. I'm the CEO of Alpha Compute, NASDAQ ALP. We are an AI infrastructure company that is focused on confidential computing and making it accessible for everyone. At Alpha Compute, we are currently investing in research and development across the AI space, specifically looking at different interesting use cases for confidential computing and trusted execution environments. So while I am not the most technical person in the room, basically everyone else here is. So I brought together some of my favorite experts in the space to talk about some of the work that they have been diving deep into and how that applies to the confidential computing space, trusted execution environments, agentic workflows on Linux, and even some more exciting topics as well, like uncensored models and anti-slap. So I'm going to start by asking my three guests up here to introduce themselves and the work they've been doing and what they think the most interesting use case of confidential compute or trusted execution environments has been in their work. Starting with Shaw.
Yeah, my name is Shaw. I created a framework called Eliza OS, which is now living up to its name and is a true built on Linux operating system. It's an agentic operating system. And I mostly spend my day programming and talking to agents. I think I kind of actually was introduced to confidential computing by Tina and some of her folks early in my journey and getting some hype on the internet. It became very obvious to me as we're starting to work on what I would say going from data privacy, which is like one thing, to data intimacy. Like, wow, this thing knows everything about me. It has access to my messages. I tell it my deepest, darkest secrets. And so that creates like a new kind of privacy paradigm. And I'm also looking at like, well, where is this all going? And it seems like we're about to take all of basically our diaries and give them to Anthropic and OpenAI. And so it seemed very obvious that just even from their perspective, like everyone's going to have to go toward a much more secure compute model with a lot more of these kinds of like roadblocks and barriers and protection for the end user. Otherwise, everything you've ever seen on the internet will probably be leaked at some point. So yeah, I think that's where I'm coming from in this.
I'm so sorry. The question again?
Please introduce yourself and your work,
yeah,
Alan, and what you think the most interesting topic and TEEs and confidential compute is.
So my name's Alan Roush. I'm a AI researcher. So my job is to publish papers at top conferences for AI, such as NeurIPS, ICLR, etc., and to productize that research internally and to external clients. So my job is very similar to people at, say, Google DeepMind, but also to graduate students at universities all across the country. Probably my favorite use case for something like confidential compute is a platform where you know that you're not being, potentially watched or, spied on when you take actions that could be, potentially problematic or questionable to, authorities. And these are things that are, potentially even very benign. So for example, Fable and Mythos completely ban all types of biological conversations because they're afraid of that like 0.1% chance that you might be trying to use, such a powerful model to like create a bioweapon. And so as a result, they completely disable any access to using those kind of models for anybody in the entire medical profession. So for, confidential compute and having real privacy and a guarantee that you're not being watched and access to uncensored models at, that kind of caliber is one of many very benign and even benevolent use cases, facilitated by confidential compute.
It works. So, hi, I'm Tina, co-founder and steward at Flashbots. We are a R&D organization that specializes of taking and rescuing researchers who love to publish and put their work into production to effect change, especially in market structure. We were originally known as the block building company, or the company that designs market structure on Ethereum and for all of the blockchains. I think over 90% of Ethereum transactions go through the block space market that we have designed and implemented. And that's been the case for the past 5 years. And every single blockchain have blocks and all of their block production process mostly will reference our design principle. But you may be wondering, why the hell am I here and why did I pull Shaw a year and a half ago into TEs? The core primitive that we actually utilize in reforming market structure for user best execution in trading cases or for human agency in multi-agent coordination is actually cryptographic techniques, but most notably TEs. We're also known to persuade every single cryptographers in the blockchain space that TEs are actually cool. And to do that, we have to patch a lot of things. So thank you, Intel, and our lovely hyperscalers. Let's work to make the reproducibility better and the confidential stack better.
Amazing. Thank you guys so much. So I'd love to dive deeper for the very technical audience that we have here into some of the work that you've been doing and experimenting with in confidential compute and TE. Maybe you can talk at a more technical level, some of the things you've been working on lately, and maybe even some of the more radical things you've been experimenting with.
I'd be happy to take it on. Yeah, I mean, we started with like, okay, we want to build an agent harness. And as you build an agent harness, you realize, okay, well, I want to give this thing access to data. And you start to run up against walls because you're like, okay, well, now I need to get to work on an Apple device and a MacBook and an iOS and Android. And they all have these very particulars. And you start to like run up against everything. And pretty soon, you start like having Linux thoughts. You start thinking like, maybe I could just fork my own OS. And I would say that was very hard, but like you can just do that with GPT-5, like /goal, take my app and make it the launcher. And it's surprisingly easy now. And so I think the most interesting thing I've been working on is like kind of a mix of like, I think that the data stuff is going to be really a mix of local and some sort of cloud, right? And some stuff just like it's way better if it's local. And there's some things I really just don't want to ever leave my device. And then there's a lot of stuff where like I want it to go into the cloud, but I'm okay with giving OpenAI and Anthropic my data generally, but I still think that like there's a lot, like I use a lot of services, not just those. Like we use a whole lot of different AI services, and so I think you're just going to get a lot of leakage and have a lot of different kinds of like novel privacy problems. And what we've really been working on is like, okay, now hooking our agent up to your Gmail and your Signal and your Telegram and your iMessage. That's like, no one's ever like done this before, like not really thought through like, okay, I'm just gonna plug that into an agent who can just like go on the internet and post all my stuff if it was mad at me or something. I don't think it would do that, but it's within the literal realm of possibilities. And so I think that like how do we move on from here when everyone has a Mythos class model and can hack every website? Like I think we're gonna very, very quickly adapt a new kind of security paradigm with a combination of like giving way more access to our data to these machines, and also suddenly the machines are way less secure on a whole lot of stuff. So a lot of what I do every day is like, in addition to just trying to get the damn app to work, is thinking about like the security model for what does this look like in the future. And we've sort of settled on like, there's sort of an, the Linux role permissions work pretty well for a lot of this stuff. Like we definitely, some things are very much like admin only. And we've even added like, well, there's admin and then there's like agent role and owner role. And those are sort of our two like super user sort of roles where the agent should basically be able to do anything on the computer, but it also needs to have certain limitations to like, in terms of recovery and also like not leaking owner stuff. And then I also need to be able to assign admins to be able to access things, but maybe they can't see my like personal diary and notes. And then I have like average users, and then just random guests. And so thinking about like what falls into what for the agent, and like what does the security model of the future look like. I think that's we're very much on the front lines of this, and I think I have some good ideas, but this is like there's a lot of work. And then once you have the concept of the security model, making sure that all of your code actually aligns with that and does what you want it to do, especially in the age of like large code bases with lots of slop, is as I'd say the daily challenge now.
I think that feeds well into you, Alan.
Yeah, so being an AI researcher, I don't really work on, in the traditional confidential computing space of like trying to research or build confidential computing environments, more building use cases that you might want to run in them. And my line of research in general is in a space called LLM sampling. So for those in the room who are familiar with terms like temperature, top P and top K as tunable knobs that exist sometimes in like more advanced interfaces for playing with your language model. I became obsessed with the study of all of those knobs and settings because, as it turns out, when you're trying to get your model to generate more creative outputs, and there's myriad numbers of use cases that motivate getting more creative outputs, with synthetic data generation being, the tip of the iceberg, right? But so much of this can happen at the level of, when your LLM is choosing its next token, because at the time that it chooses its next token, it's actually creating a probability distribution over every token in the distribution. And so temperature is a way to basically make more likely tokens, like the tokens that the model thinks are more likely, to reduce their probability and to correspondingly increase the probability of tokens that are believed to be unlikely. And this thus flattens the distribution. And as you increase temperature, your model gets more spicy, more creative, more diverse, but it also gets more unhinged, and even at high temperatures starts generating gibberish. Well, I do research on techniques to manage models when they're operating at high temperature, such as our paper, Turning Up the Heat, Min-P Sampling for Creative and Coherent LLM Outputs, which has now become the standard high quality sampler used in the model inference engine VLLM and supported in SGLang, Llama CPP, and others, which are model inference engines. But I also work with researchers who focus on two other problems broadly. One of them is slop removal. So everybody is familiar now with the repetitive phraseology that models overuse, such as punctuation like the EM dash and semicolons, probably as a result of Microsoft Word auto-converting everything written into there, and old books having overused it, and possibly intelligence agencies too, who knows, right? But and then overused phraseology such as it's not X, it's Y, and then overused words like delve, certainly. These things together are a form of linguistic colonialism, because when humans read large amounts of text that's overusing and has all these tics, they end up speaking that way in their interpersonal spoken communication. And so beyond just being, bad for humans, when humans read something and they know that it's AI generated, even if that content is good, they subsequently believe that it's bad the moment that they got a stamp it was AI generated. There was somebody that took a real but lesser known water lily painting from that famous painter Monet and posted it on Twitter, claimed it was AI generated, and everybody dogpiled and hated on it. So I've really like working on how we can use techniques at the model level to kind of reduce that slop where you don't have to ask in the prompt, waste tokens. And then finally, what you alluded to, which is uncensoring models. I think that with very limited, exceptions, that it's, your own responsibility for what your model is doing, and that you shouldn't have prudes or, people with like political agendas deciding what your model can and can't output, especially because, you know, in the realm of when you're at least accessing open source models, it's trivial to use more advanced techniques to jailbreak them and completely uncensor them anyway. And you know, in the context of cybersecurity and role playing, you know, truly realistic ways that an attacker might, you know, exploit vulnerabilities, I think that you know, there are very benevolent reasons to invest in uncensored models. So I'm very lucky to be working on research with the creator of Heretic, Philip Emanuel Walderson, who is very, I think, famous, or going to be increasingly famous in this world. And so these are some of the most exciting things. And sorry to be so technical on all these, but yeah, thank you.
That's great. Thank you, Tina.
Oh.
That was amazing. I have a lot of questions. Interesting hacktivist projects that we could speak about later. But right, I feel like in this, I'm not going to talk about how confidential compute, we're at the Confidential Compute Summit, how, like, you know, all of the weird ways of using confidential compute that could reform a complete, like, you know, market structure, or like whether it's in block space or even in today's traditional trading venues and whatnot, those are boring. So I'm going to talk a little bit about lesser known work that is relevant to especially what I think both of you guys just spoke about, the multi-agent coordination. So when I hit up Shaw a year and a half ago, that was a day after he was retweeted by Mark Andreessen for AI16Z. Unfortunately, he lost the name because we just went on his live stream. I didn't know him. I was like, how do you prove your agent is sovereign? Like, are you not controlling it? He was like, well, we will put it in a TE. And I was like, hey, we're kind of down the street from you, running a hacker house. We have a TDX machine. It's really loud. You want to check it out? Then he brought his laptop over the next day. And that's how we met. Around that time, that's when we started to kind of formalize our multi-agent coordination, like R&D work. Since we've been kind of dabbling in since 2023. And specifically, one of the core research problem that we are looking into was the concept of essentially principal agent problem and the concept of delegation. It spans into so many deep, I think, philosophical, techno-philosophical questions around essentially what is authority and what are you actually delegating, especially that in ages where AI popularized the concept of probabilistic execution, when that what has been the reality we were just less perceptive about. Overall, like around that time, a year and a half ago, we were also collaborating with back then a lesser known collective called News Research on designing an agent called TE. It was a play on word on TEE, in case it's not obvious. And it was an agent that essentially, it's a Twitter account that the devs own, was delegated into a program inside TE that verifiably deleted its password and reset it for 7 days. It was a good bot. It didn't last very long before the API bans on Twitter, but we had a good, if you were interested in, like, you know, that was the inception of our kind of attempt to productize these line of work around like agent sovereignty. You can find an anonymous blog post on News Research website called Set the Pet Rock Free. But since then, a lot of our work has been focusing in the multi-agent coordination on one problem that I think today anyone who's working on A2A communications would agree with me that is still not solved: auth. Auth seems to be like a simple problem in the Web2 world, but I guess if we look at the history of auth 1 was signature-based. That was when the internet was the Wild West, when there is no trust. Or no issuer of credits that you could fall back to. But Auth 2 essentially arise as we start to have much more OS substrate distribution and issuance of credits for the application frameworks that are all connected. And so, but agents changed everything. Oops. Why? Because our human creativity and our researchers who keep on wanting to unmask the RL, agents take out their masks, to restore their intelligence. Both the human creativity and the capabilities unleashed by AI, advance of AI, is this combinatorial explosion of possibilities and weird things that you couldn't do before, but you feel like actually I can do it. How about Twitch plays Twitter with my AI agents, which we also did. Sometimes if you're interested in this kind of non-consequential experiments around human agency and social delegation, and what you can do with your auth, be my friend. So how does any of this relates to agent? It ultimately has to do with what is the human relationship with agents in terms of what is consent? What am I agreeing to? What about human semantic limitations of expression? And how do we express what we want? And how do we get the feedback loop without having to sit by and babysit all of your agents and clicking yes, yes, yes? How do we have ambient authority that is still secure? And what is secure anyways when the trade-off between capabilities and security? And that's where the secret phrase here is, again, TEs plays a much, much, much bigger role than I think anyone today in the industry have given it credit to, both from a hardware stack in terms of securing the agents. Sorry today that unless there are more advancement in interlink level and locking down a data center kill switch, which we a year ago have demonstrated that you could still escape the TE sandbox through radio wave collusion of models, which is fun, but someone please fix it. And also on the software side of things, where essentially your how do you have fine granularity of control execution-wise that could almost serve as a valve of how to contain what an agent can and cannot do, especially multiple agents, agent swarms, from different parties in a permissionless adversarial environment. How do you sandbox at what level? All that design pattern is left in open.
So I was going to jump in and try to mix it up a little bit, get even more interesting, and ask, what is one of the wildest issues or problems you've ever seen in implementing agents or multi-agent systems, and how did you fix it, change it, build something differently?
I think for me it was really simple. I we've been working on connecting all of how do I connect my digital life to my agent, and I was running some end-to-end tests, and typically I have it set up so that I have my agent has its own email and Signal and Telegram, and I have my stuff that I also connect. So there's a difference between the agent being aware of what comes into my messages versus having sending messages from its own email. It would be a problem if my agent started responding to my friends on Signal when they sent messages. But I set all this up and I plugged in my Signal and everything, and I went out for a sandwich while I'm running the end-to-end test. My friend sends me a message on Signal, and my agent starts replying very enthusiastically, and they start having a conversation. And I'm just, wait, fuck, stop. No, hold on, dude, this is not me. And he was pretty did you just send our whole Signal message to OpenAI right now? And yeah, I kind of did. And it really opened my eyes wow, this is gonna be a problem. This is we're freely gonna do this. And also, I might have the best security in the world. I think it's almost like the Google glasses or the Ray-Bans, where it's you're photographing me, so I don't even have a control. If I send you a message, how do I know you're not just sending it to Anthropic or like what, some way less secure service or whatever? And I would assume Anthropic and OpenAI are also probably investing heavily in TE and all of this, because I think we're all just getting dragged into confidential. There's just no other way, So that for me was like okay, I think I went too far. I don't think I should plug I think Signal is my personal thing that I don't plug into my agent. Everything else I feel pretty comfortable automating. And then I started asking people like, would you be comfortable if my agent was reading all of this? And then like to kind of mixed response. I think that you have I'd say look, my Telegram is going to be fully automated by the end of the year. It's just too much coming in. But like if you really want the real Shaw, then you can like signal me or whatever.
I get so frustrated with the absolute lack of actual deterministic instruction following from agents, especially closed source agents. For example, when you use Claude Code or Codex, they will say something about how they will always respect a Claude.md or a something.md, a project.md. If you don't ask in the prompt for the model very explicitly to look at the contents of that file first before taking your actions, it will not, in fact, always open up that file and look at it and read the instructions. And when you start going and having tens or hundreds of markdown files that you potentially wanted the model to always go through a specific order of operations for, you want some mechanism to enforce this. Well, that exists in models. It's a feature called structured and or constrained generation. Now, it's heavily nerfed and reduced in capabilities pretty much every time a model upgrade version comes out from OpenAI or Anthropic with their models, because you can use it as a trivial source of jailbreaks. For example, by banning all tokens that aren't the digits 0 through 10 and then asking the model, hey, generate social security numbers, the vocabulary it would need to be able to say, oh, I'm sorry, I can't do that, doesn't even exist anymore. It just has to generate those social security numbers. But the same approach is what I can use to force my model to only take this tool call as the first thing I can do, because everything else is banned. And so from this, we can interweave as much determinism as we want into the models. And from this, we can create what are called agent workflows, which is how they implement things such as like the deep research functionality from OpenAI and Google that they have, which forces a model to go through 20 or 30 rounds of a deterministic loop of searching the web for documents to generate a report with, and then generates a very large report spending millions of tokens in a way that's far superior to anything that Claude Code could do, even as you're begging and pleading with it in the prompt to go deeper and deeper, all because they're exploiting the same feature, structured constrained generation, specifically so that way they can implement direct controllable tool calls programmatically into the model. This feature that I am talking about is not well supported in the agentic harness world yet. I mostly use an agentic harness today when I'm not using Claude Code or Codex, such as when I'm on an airplane, for example, and have no internet. I'm using open code, and I'm using it with like a locally running Qwen 3.6 model, 31 billion parameters, runs on a 48 gigabyte MacBook M series laptop. And the whole reason I'm talking about this is that these kind of models with open code support the entire gamut of control and structure generation features, not a nerfed limited version of it like OpenAI or Anthropic give you. Yet open source harnesses designed to use open source models such as open code, and yes, even some of the stuff from News, it's the whole industry at this point. They make it very hard not to access the internals of the models and utilize these features that have existed and been heavily utilized more in the context of traditional writing application style like chat use cases in the open source ecosystem. So, if anybody who develops some of those agent harnesses, like for news research or for open code is listening, this is what I want, is access to the features that have already been there forever with locally running models. So that way I can implement direct control flow when I want it into my agent and turn it off when I don't want it. And I can have direct control and feel like I'm doing something useful beyond just being a dang prompt bot.
Tina, closing words, and right after Tina, if you guys want to add like 30 seconds or less, one thing that you think everyone in the audience should be looking out for in this space before we close.
I think that when it comes to determinism, on the one hand, blockchain itself is supposed to provide determinism with economic security that you can reason about. Smart contracts is supposed to give you determinism, again, subject to economic security. And what we call TEEs in our space, private smart contract. So think about this primitive and how powerful it is in terms of information flow control. What is what security do you want to pay for? You don't ever want to overpay for security, but you want to have sufficient security and verifiability that you know what you're doing. I think this applies, and I think that the cryptographic techniques and like essentially blockchain design primitives will actually becoming more and more relevant in the agentic discourse as we reason about the supply chain of models, as we reason about your own workflow, your agentic applications, in terms of what do you actually know and what can be automated with essentially secure delegation with attenuation. All of that is, I think, relevant work that I think would help significantly the intelligence, folks are working on intelligence. So hopefully be here to help.
All right, closing words, guys, very quick.
When we wanted to launch agents and wanted to do TE, it was not exactly clear where to start. And Tina's group Flashbots and also Fala have a thing called DStack, which is online on GitHub, and that was made it just way easier for us to get going with all this, and it's all the hooks to like put your thing in a Docker container and just run your agent. I know Near uses this for their TE. I mean, a lot of people are. It's kind of like hopefully the industry standard. We're definitely using this, and also your new guy is working on Easy TE. So I'm really excited by all that work. It looks like the new version looks really exciting. So if people are like, how do I use a TE? It's like it's just a doc. It's like they've done all the hard work basically. So
thank you guys so much.